So we're looking at page 8 in Unit 1. This type of graph is substantially easier, the box plot, than what we did on the previous page. Not in the sense that it's conceptually easier, it's just the mechanics of it go a lot quicker. All right, so we have our raw data set, and so what I'm going to do is I'm going to pop that into the calculator, into the Desmos calculator. I'm going to get rid of all this stuff. You know what, let me open a fresh new one. New blank graph. So I'm going to hit the little plus sign to type in some data. This is all one set of data. So the same data set here that I have for the stem plot, we're going to use that for the box plot. It's the same set of data for the histograms, box plot, the stem plot, and later on the dot plot. So I'm going to type in the 80, the 91, 90, and so on. Just double and triple checking to make sure that there's no little mistake along the way. Alright, so just popping the data in. And all into one column. Alright, just because you see 2 rows of data doesn't mean it's a frequency table. It would say frequency if it was a frequency table. Alright, not the case here. Alright, so I bought myself enough time by blabbing on here to type the information in. I'm just going to do a quick double check. 50, I'm going to do check it backwards. I like to check it in a way different from the way I typed it in. Just so I don't, if I'm going to make a mistake, it's probably a different mistake. I don't want to make the same mistake twice. Alright, it looks like I got it all. In theory, correctly. Alright, so we can do a couple of things here. One is we can get the 5-number summary. We do that by hitting function. We go to stat. Right, so I'll jot this down for you. I said almost rot. I said rot. That's weird. We need the 5-number summary. Right, we do function. We go to stats. And then we select stats again. There's another icon there that says stats. All right, so you select stats. And it's kind of weird. You know, I kind of wish the command was a little bit more friendly than that, because in a stats menu, you would think that everything would be in some capacity stats. So to have another command called stats is confusing, but that's what we're doing. We put all our data in X1. So I'm going to type the X1. And so what we're going to have here is this line code or line command, which is stats X1. And what it gives you is what's known as the 5-number summary. And this should look fairly familiar in terms of concept. The minimum, Q1, median, Q3, and if I scroll down, the max. All right, so I can jot these values down on the side. Minimum, 0. Q1, also known as the lower quartile, is 53. The median, 77.5. Q3, 90.5, and the max, 100. Now we haven't created a graph of any kind yet, but it's not really as important as getting these numbers. Apologies, I got a frog in my throat still. If you listen to the last video, you know there's a frog in there. You know, so we just got to plot this information. But the big question is, you know, always big questions. What does the box plot look like? It has the form specifically. I should probably use a line draw tool for this, but it's going to look something like this. Let me fix that one there. I'm going to keep it a hand-drawn figure, but I'm just going to try to make it look a little nicer. I erased it and I pretty much drew it exactly the same way. All right, with the lowest point being the minimum. This first line being Q1. Let me shrink that down a little bit. the second line being the median, then Q3, and then the last one being the max. And it always has that structure. Doesn't always look that way, but it always has that structure. So what we want to do is create a number line that has all that information. So my lowest value is my minimum, 0, and my maximum, 100. So I'm going to set my scale to go from 0 to 100. All right, and I'm going to break that up into even increments. Now, how you do that is up to you. You split it down the middle, that gives you 50. Split it again, gets you 25. Split it again on the other side, 25 away from 50, 75. And then if you want to go even further, you can. If you create 4 evenly spaced tick marks, you'd have 5, 10, 15, 20, 25. I wouldn't go labeling all that because it kind of defeats the purpose, you know, because it makes it kind of a big old mess. The whole idea is to establish your ruler, and by ruler I mean scale. I use the terms interchangeably, and you'll see when we talk more about standardizing that term ruler is going to come up more and more frequently. All right. So at some predetermined space above this ruler that we just created, based off of our minimum and our maximum, those are the 2 defining points of our ruler. How we space it out is up to us. Some predetermined space above that, we plot the 5 points corresponding with those numbers, 0, 53, 77.5, 90.5, and 100. Now, we're going to have to ballpark it, but that's okay. So here's 0. 53 is going to be just shy of 55. 77.5 is going to be halfway between 75 and 80. 90.5 is going to be a little bit east of 90, and 100. Now you can see here that I'm really being fast and loose with these points. All right. So all we're going to do is draw a big old box around the middle 3. A shaky line box. And draw a vertical line where the median is. That's the 77.5. And then extend it out to the extreme values. Oh, I didn't put my line draw tool on. Oop. That's a cool feature that I didn't know existed, but that's not what I wanted to do. And so that's what we're looking at. And I get a little extra fringes here that I'm going to get rid of. Oh, too much. I'll just leave that one. All right, and that's generally what the box plot is. All right, now you can see that doesn't look a whole heck of a lot like my general structure diagram, except to say that it's got a box and it's got a bunch of lines in it. But the main bulk of the graph is shunted all off to the right, whereas the crappy drawing I drew on the left-hand side is roughly symmetrical. All right, so that's possible. The whole idea is that when we create a box plot, it's going to give us a sense of where the bulk of the data exists. All right, and so this, we wouldn't have to label this if I asked you to create a box plot, but just so you have this information. Oh, that is a heck of a squiggly bracket. That's a squiggly bracket that we all know and love. This is our interquartile range, IQR. All right, and so that gives us a good sense of where the bulk of the data exists. Box plots are great as a comparative plot. Right? It's good for comparing one data set against another. As you can tell from the histogram on the previous page, histograms aren't really friendly when it comes to comparing data sets to each other. Box plots are really friendly when it comes to that. All right. Now, as far as Desmos is concerned, odds are, and this is kind of a rule of thumb when it comes to just the way I think about Desmos. If I'm not sure if Desmos does something, I just start typing the command. You'll notice that prior to completing the term box plot, it was all in italics. But then once I put the T in there, now all of a sudden it's regular font. If I open a set of parentheses, and put in the x1, yx1, because that's where the data was or is, it created a graph. Now it has some features here, some interesting features. It says offset, it says height. I wonder what those things mean. Exclude outliers. That's a cool attribute for Desmos that, you know, if we reflect back on page 2 of the notes, that actually is, I don't want to call it a game changer, but it's pretty significant in terms of its meaning. But for now, we're going to turn that off. All right, I'll explain what that means in a minute. But let's zoom out here. It'll pinch outward. And you have a graph that goes from 0 to 100. Our graph went from 0 to 100. That box, if you can kind of bring it in, make it look somewhat reasonable. It's kind of hard to do so when it looks like this. I mean, this is kind of ugly. But that it looks a little thicker and a little bit to the right of 50 around 90. That's kind of the same as ours. But if you change the offset and the height, things are going to get a little bit more recognizable. Let's say we make the height, let's make that 5. That height is giving, when we change the height, it's changing the height of the box. All right. So let's say I want that box to be as substantial as the one I drew on paper here. Why don't we make that 20? Oh, that looks pretty substantial. But now it's right on the x-axis. I don't want that because I plotted my graph above the x-axis on paper. So that's what the offset is talking about. I can offset it by 10. It's still on the x-axis. Maybe I'll go up by 20. All right. So what that does is it gives you the location of the box plot, but it also affects the height of the box itself. All right. So it'll give you a cleaner looking box plot, something that's a little bit more consistent with what you drew on paper. It's a great way to check your work. All right. Now, if you hit exclude outliers, what this will do is it'll eliminate any outliers that exist in the graph, right? And also, I did it very quickly, but there's that little magnifying glass. If you tap on that, it'll create a zoom in Desmos that Desmos thinks is most appropriate for your graphical display. I probably should have said that I was doing that before I did it, but I think if you rewind the video, you can see what I'm talking about there. All right. And then, you know, if you tap on this jammy here, the one that looks like a little box plot, you can turn it on and off. That's good for comparative purposes. If you have multiple data sets and you want to look at them one at a time, you have multiple box plots on your graph and you want to look at them one at a time or all at once, you can toggle this back and forth on and off. All right. We still want the 5-number summary, the stats x1, in order to give us the values, but we could also use box plot to give us a nice display. All right. So that's the box plot. Now the stem plot is actually pretty easy conceptually to do by hand. It's just, I don't want to say tedious, because then I open myself up for criticism, because you can kind of look back at the last 3 graphs that we created and say, wait, this one is the one that's tedious? What about the last 3? You know, so I want to be fair about this. I mean, creating graphs by hand I want to be reasonable. These things can be pretty tedious no matter how you slice it. But this one is a little bit more painstaking, you know. So what you do is you create 2 columns, one bigger than the other. The first column is called stem and the other is called leaf. All right, a stem plot is also known as a stem and leaf display. I don't call it that because that sounds, well, sounds dumb. Stem plot sounds less dumb, so that's the one I go with. All right, so what we do is we partition numbers into parts. All right, so if there's a 2-digit number, what we would do is we would partition that right down the middle, partition or split right down the middle. The left side of that partition we'd call the stem, the right side we'd call the leaf. And we would do that for every 2-digit number. Oh, let me just do that a little off over to the side here. So every 2-digit number. Now, the obvious question's got to be on somebody's mind, because you're looking at 100 and a 0 right below it. What happens if it's not a 2-digit number? I'll get to that in a sec, because I'm using my exponential relationships here to graph this, or well, to partition these values anyway, a little bit quicker. Of course, it's quicker, just not quick. Probably could have wrote it faster. It's like the story of my life when it comes to note-taking. Every time I try to do a little shortcut with the technology, I end up making my life more complicated than it needs to be. I have this extra fluff here that I want to clean up. I don't know if fluff's the right word, but honestly what I'm just trying to do here is buy myself time until I finish marking this up. All right. So I got all these 2-digit numbers in the second row that I could do the same thing with. I could split them to a stem and leaf, each one of them, with my shaky hand. I might have to adjust a little bit, but I'm going to change the color so it pops, stands out a little bit. All right, but then we got the elephants in the room. We got the 100, the 0, and another 100. Well, let me just kind of look at this 55 over here for a second. If we name this, let's go back to elementary school here and name these 2 digits. This would be the ones place, and this would be the tens place. All right. So that's useful information because, and we're going to neglect these values for a second and just think about, the ones that I didn't mark up, the 100, the 0, and the 100, and just talk about the stems that we have in the set of values that I have marked up. The lowest one I have there is a 1, and the highest value I have there is a 9. So the lowest stem seems to be a 1, with the highest being a 9. All right, that's because I have an 11 here. That's the lowest one out of the ones that I have marked up. That's the lowest, and a 9, for example, over here. That's excluding the 0 and the 100. Now, if I look at it a little bit more carefully, I could say, wait a minute. Can I represent 0 as a 2-digit number? Well, yeah, I just tack a 0 onto it. If that's the case, then what I can really do is think of that 0, 0 as a stem in the tens place of 0 and a leaf in the ones place also of 0. All right, so my lowest in terms of stems would no longer be the 1, it would actually be a 0. Now for the highest, it's a little trickier because it's a 3-digit number, because it's like, where do I put the split, right? So do I put it between the 1 and the 0, or do I put the split between the 2 zeros, right? So do I put it here, or do I move it over and put it here? Well, the short answer is, since this still represents the ones place, we could look at this as collectively representing the tens place. Even though it doesn't quite make sense, I can look at this as quote-unquote tens place by saying over here I have 110 plus the 1 gives me 11, but here I have 10 tens plus 0 gives me 100. All right, so it actually tells me that my highest stem ought to be 10. All right, so if we place it so that the partition is between the 0 and the 0 in the number 100, then we have what we're looking for. Our stems would span from 0 to 10. All right, Now you might look at this and say, well, I don't have a value that's in the 30s. So why do I have a 3 as a stem? Well, we have to account for every value that exists between the lowest and the highest. All right. Why? Good question. I'm glad you asked. The reason why we have to account for those values is because the absence of data is just as important in statistics as the presence of data. Why are data values excluded? Why are data values included? They're both important questions. All right. So we have all that information. Now, for the time being, what I'm going to do is I'm just going to clear this out. I'll just cut it. I'll put it back in a couple minutes. But for now, I'm just going to cut it and just take a look by saying, all right, I got a stem of 8. All right, because now we have a good idea what our stems are. All right, I got a stem of 8. What does that correspond to in terms of a leaf? It corresponds to a 0. So I put a 0 in the leaf column in the 8 row. So now I've taken care of the 8. So now I'm looking at the 9. I have a stem of 9 with a leaf of 1. So in the 9 row, in the leaf column, the first entry in the leaf column for the row 9 is going to be the number 1. We got another stem of 9, which corresponds with a leaf of 0. All right. Ultimately, this is a graphical display. So what we need to do is make sure that our spacing is consistent. No commas, consistent spacing. So whatever you decide upon from your distance from the vertical to your first line, that should be roughly consistent the rest of the way. All right. Now there's of course wiggle room because you've seen some of my graphs. All right. So there's understandable deviation for that. As long as you're trying, it's okay. But you gotta make sure you're giving it an honest effort there. So 51 has a stem of 5, a leaf of 1. 75 has a stem of 7, a leaf of 5. 83 has a stem of 8, a leaf of 3. So it's a second entry in the 8 row. We got another 83. So I get another 3 in the 8 row. I get another 80. So I get another 0 in the 8 row. 95 twice. So I'm going to put a couple of 5s in the 9 row. 100. All right, now this is where we get interesting here, because 100 is a stem of 10 with a leaf of 0. All right, it's the first instance where we have to look at it kind of differently the way we did from before. All right, the 0 was a stem of 0 and a leaf of 0. I deleted it, but it's still the same idea. 0, 0. So a stem of 0, a leaf of 0. We got another 100. So another 0 for the 10 row. And you see how this graph is shaping up. Doesn't look like much of a graph, just looks like a list of numbers. But the length of each row is creating a shape of a distribution, a graphical distribution. That's going to be meaningful for us. So I get another 75, so another 5 for the 7 row. Another 75, so another 5 for the 7 row. 56, so a 6 for the 5 row. A 2 for the 4 row. A 5 for the 2 row. A 1 for the 1 row. And a 5 for the 5 row. All right, stem of 5, leaf of 5. All right, and the only thing that you need in addition to what we just created here, that's the stem plot, is you need a key. It might seem weird. Say, we did all that. We have a raw data set. If you're ever presented with a graphical display, very rarely are you going to be presented with the raw data along with it, because we're working with small data sets here, but in the real world, data sets are very lengthy. So you're not given the data set. What you're given is a graph and a way of interpreting the graph. So what we do is we just grab an example. And this is an absolute requirement. You just grab an example from your stem and leaf chart, your stem plot. For example, 9, 1. And just tell the reader what that means. That's the number 91. All right, as long as you do that, you're good. You don't have to give more than one example, just one example. All right, because the reader doesn't know what methodology you use to come up with this graph. All right, you'll see examples when you go through the OpenStax textbook where, you know, the data set, it consists of decimal values like 8.0, 9.1. You can partition a number wherever you want. Some people are going to partition it, if it's a 3-digit number, between the first and second digit. Some people are going to partition between the second and third digit. And that'll impact the shape of the graph. So you got to be careful about stuff like that. All right. The last type of graph is called a dot plot. Dot plots are easy conceptually, but sometimes they're kind of more trouble than they're worth. So what we do is we create a number line, just like we did for the box plot. All right. We got to go from 0 to 100. All right. So I'm just having an internal debate. You know what I'm going to do? I'm going to call an audible here. I'll take this as a typo. I'm going to make up a brand new example for this. So first time in 20 years I'm doing this. So example, let's say we have a raw data set of 1, 1, 2, 2, 5, 7, 7, 7, 7. Right? Something very simple. And we want to create a dot plot from this. All right. All we would do is we would account for the lowest number and the highest number and create an evenly spaced interval based off of those values. You don't have to use the whole number line. I made a really big number line because I had anticipated using the numbers listed above, but that's a little crazy. So we just need to go from 1 to 7. All right. And then all we're going to do is above each one of these numbers, we're going to plot a point for each one of the values that we have. All right. So the number 1, for example, I got the number 1 twice. So I'm going to plot 2 dots, evenly spaced from the number line. 2 occurs twice, so 2 dots, evenly spaced, roughly evenly spaced. That's the best I can do. 5 only occurs once, and then 7 occurs 4 times, so 4 dots for the 7. Evenly spaced. All right. The spacing needs to be consistent from set to set. So for example, this spacing here has to be the same as this spacing here. Roughly. So it's got to be equal spacing throughout. All right, these red markings that I just indicated here, they're supposed to be like little brackets. I apologize, I really can't make it look any nicer. Trying my best. Yeah, you don't need those to be part of your graph. In fact, maybe I'll get rid of them. And I'll just draw a little arrow. Maybe that'll look a little bit better. All right. But that's essentially a dot plot. So we didn't need to go too crazy with that sort of idea. It's good for small data sets with lots of repetition.